We are going to look at some transformations now, and our first transformation is called a translation. So I know the word transformation sounds like translation, but transformation is general. Translation is a specific type of move. I know they sound a lot alike there, but a translation is a slide, okay? So the key here is that when we talk about translating a shape, a translation equals slide. That's really all that you need to know, okay? Or the big idea, I should say. Translation equals a slide around the coordinate plane, okay? So we're going to move all the points in the same distance and in the same direction, whether it's up, down, left, or right, okay? So first thing we want to do is we want to describe this with a rule. And then we're going to talk about something called a vector, all right? So here we have a shape, the original. The original is the blue one. And it has moved. We've got 3 points, A, B, and C, and they're going to move. A is going to move to this one. This little A apostrophe, we read that as A prime. Okay? That's called A prime. Right? It's the new A. And C goes to the new C. And B goes to the new B. The new B there, all right? And if you look at those, we see what's going on here. Well, they're all going left 4 and up 1. This one's going left 4 and up 1. B is going left 4 and up 1 to its new place. So the key here is that we're going left 4 and up 1. Now, that's how they're all moving. They all move the same. Now, if we look closely at their coordinates, we can see something interesting happen. This is the coordinate 4, 3, and it goes to 0. This new coordinate is 0, 4. Let's look at C down here. This is the point 4, 1, and the new one is going to 0, 2. And if we look closely, we can see what's happening. The X is going down 4, and the Y is going from 1 to 2. That's up 1. From 3 to 4. It's getting bigger. So the Y is getting bigger, and the X is getting smaller, actually, in this case. And so the way we write that is this. We say, if you take some point in this triangle, there's a whole bunch of points, not just those 3 points. There's all these side points. But if we take some point x, y, and we're going to change it, well, what happens? The x is going to lose 4, and the y is going to gain 1. Can you see the connection? Up 1, that affects the y. Left 4, that's like going negative 4 in the x direction. All right, so that's the idea there. Now, if we wanted to switch it around and say, let's go the other way. Let's go from A prime, B prime, C prime to ABC. So in other words, we're going to take these arrows and we're going to switch them around, basically. All right, so if I can erase those and let's just say we're going to switch them around. Well, the only difference is now this x coordinate here of 0 is becoming 4. And this one's going to become 4. So it's actually getting larger. So now if we're going from x prime, y prime, or A prime, B prime, C prime to ABC, we're going to be doing the opposite. We're going to add. Now in most cases, we'll be going towards the primes. That's the new one, but it's useful to think about the other way around here. Okay, and what's happening to the y's? Well, the y's are shrinking. 4 goes to 3. This y value of 2 goes down to a y value of 1. So y minus 1. Okay. So that's what we call a coordinate rule, all right? So this is a coordinate rule. Let's jot that down. This is a coordinate rule for a translation, all right? It just tells us how the x is changing and the y is changing. Now, so with that, we can try to make some transformations here. Here we got a quadrilateral A, B, C, D. And we've got its vertices given, so I'm going to graph those. You can pause the video and graph it too. Make sure when you graph those, you are labeling the points. That's going to be real important, okay? Now, we want to find the new points, A prime, B prime, C prime, and we're going to use this rule. So we'll notice that the coordinates were given to us up here, okay? So we got our coordinates, and so we're just going to find the new coordinates. So we can just do the math. Just plug in, for A, let's plug in -1 and 2. The new one, -2, 3, becomes 2, and 2 minus 1 becomes 1. Not too tough, huh? Then let's try the next one. Let's try B. We plug in -1 for x and 5 for y. -1 plus 3 is 2. 5 minus 1 is 4. That's all there is to it there. All right. And then let's try, all right, that's that one. Let's try C, 4, 6. 4 plus 3 is 7. 6 minus 1 is 5. Great. Now let's try 4, 2. So we got 7, and 2 minus 1 is 1. So that gives us our new points, okay? So our new points there are 2, 1. We can go graph those. 2, 1 is there. That's the new prime. We'll label A prime, the new A. Then B prime is 2, 4. 1, 2, 3, 4. There it is right there, right? Hope I counted that right. I think I did. B prime. And then C prime is at 7. 1, 2, 3, 4, 5, 6, 7, and 5. 1, 2, 3. There it is, C prime. And the last one is at 7, 1. D prime. And we can draw in our quadrilateral. Okay, there it is. There's the new ones. Now, notice this. Remember we said that these numbers just tell us the direction. The x number is going to tell us left or right, and the y number is going to tell us up or down. So what are these numbers telling us here? Let's look, because this can help us in the next ones here. Okay? So this is telling us this plus 3, that's going to go right 3. And this minus 1 is going to go down 1. And look what happened to each of these. The B went right 3 and down 1. The C went right 3 and down 1. A, right 3 and down 1. D, right 3 and down 1. There it is. So we can find the points and we can graph it pretty quickly if we just think about the direction. So let's look at this next one. What's this going to do? Well, the x is the horizontal direction, so the plus 1 is going right. X is left and right, so this is going right 1. And the y direction is going plus 2. Well, that's up 2. So let's graph the points for this triangle here, RST. So we got our triangle. So our new points are going to go right 1 and up 2. So if we go from here, right 1 and up 2, that's going to be our new point right there. See that? That's S prime. Okay. Here we're going to go right 1 and up 2. It's going to be right there. There's our new R prime. Sometimes it gets a little crazy because things are all mixed up here. Then we go right 1, up 2, right there. There's our new T. So to get the drawing pretty quick and easy, and now you can go from the drawing to get the coordinates, or we can, to list our coordinates, we can just plug in the numbers, right? And so you can do this in any order and different times. There'll be, one will be more useful than the other. So again, let's plug these numbers in here. 2, 2, 2 for x, 2 for y. That's going to give us 3, 4. And check, that's where the point is. S prime, we're going to plug in 5, 2 into 5, 2 here. That's going to give us 6 and 4. And then we're going to plug in 3, 5 into here. 3 is going to give us 4 when we add, and then 7. 4, 7. All right? So that's the idea. We'll practice some more. We'll look at one more here, and what we do is called a composition. But remember, the key here is a translation is a slide. Couple key things here. A translation, whenever we have a translation, we always get a congruent figure, okay? Or it's what we call a rigid motion. So a translation is a rigid motion, meaning it doesn't change shape. It is a rigid motion, okay? So it doesn't change. Rigid is something we'll talk about over the next few days. It's something that doesn't change the shape. It's going to be congruent in every way. A composition theorem, it just says that if we have two translations, it can be represented by a single translation, okay? Two translations can be written as one translation, okay? All right. So that means, sometimes we can just break it up into 2 steps, and that's the same as a particular one-step translation. Okay? So here's what we call a composition. A composition is when we're going to do 2 moves, all right? So here we're going to focus just on the first one, and then we're going to do the second one to the result there, all right? So let's grab here just a line segment. -8, 5 is R, and S is -6, 8. There's S. All right? Now, what we're going to do is we're going to do the first translation, and I'll kind of color code this here. Let's go blue. All right? So our blue will be our first one. Now we're going to go +5. That means right 5. So we're going to go right 5, and then we're going to go down 2. Okay? So for each one, we're going to go right 5, 1, 2, 3, 4, 5, and down 2. It's going to be right there. That is S prime. Then we're going to go right 5, 1, 2, 3, 4, 5, and down 2. It's going to end up right there. And that is R prime. Now again, these should be exactly the same shape. Take a look. They're the same length, different color because I graphed them in different colors. But it's the same length. All right? That's important. Now, what about this next one? Well, what we're going to do is we're going to look at this guy here, and we notice this is a -4. So this is going left 4. And then the -2 is going down 2 more. Okay? And so from here, what we're going to do is we're going to go left 4, 1, 2, 3, 4, and down 2. There it is right there. And we're going to call that R double prime. And then we're going to go left 4, 1, 2, 3, 4, and down 2 to right there. And that is S double prime. Okay, so we're going to put 2 apostrophes. It's like the new point. All right? And the coordinates here end up being -7, 1. That's the new R, -7, 1. And then, what do we have? -5, 4. Okay, so -5, 4. All right, so that's a translation there. Okay, now the one last question is this. Let's see if we can write this as one translation. Well, what happened? Just look, we added 5 and then subtracted 4. What's that the same as doing? Well, if you add 5 and subtract 4, that's the same as just adding 1. Look, plus 5 minus 4 is just plus 1, right? And if we subtracted 2 and subtracted 2, that's like going down 2 and down 2. Well, that's the same as going down 4, right? Y minus 4. Notice, minus 2 minus 2, negative 2 minus 2 is going to be negative 4. So our rule, if we wanted to do this in one step, we say xy goes to, with that arrow, x plus 1, y minus 4. Okay? So this would have gotten us straight from the red to the green. All right, hope that makes sense. Great job. So we'll practice some more translations and get into some other transformations next time.